Hi everyone. In this video, we are going to learn how to upload data to Apache Spark using R. This is one of our multiverse video series, and I'm Javier Luraski. Now, for this particular video, we are going to use Amazon EMR, but the learnings that we are going to present can pretty much be applied to other cloud providers like Google, Microsoft, IBM, Databricks, Qubole, and why not? Right, so let's get started. So, as a preparation step before starting this video, what I did on my own was creating an EMR cluster. Now, if you're not familiar on how to create an EMR cluster, it's not that hard. One of the things that you need to consider is, I would search mostly for Sparkly R and EMR, and there's a couple good tutorials out there online on how to create your cluster. This is not a fancy cluster whatsoever. It actually only has one driver node. And that's pretty much it. But if you need a bigger cluster, you can simply add more machines when you create it, or add them later on demand. So yes, again, this is pretty simple. It's just an EMR cluster. It got pre-created and it's ready for us to use it. The other interesting step is that this particular EMR cluster, the script that I use, which is the one recommended by the Amazon Web Services team, actually pre-installs RStudio on its own. It installs, I believe, currently an older version, which is 1.1, but you can also switch the script to use version 1.2 of RStudio, and it's not that hard. Anyway, so this is completely unrelated to how to actually upload data into Apache Spark, and in this case, EMR. So what is interesting from this particular video is to actually learn a few of the ways that you can consider when you actually need to upload data to Spark. And before we start, what we want to do is we want to load Sparkly R. If you're not, if you don't have Sparkly R installed, just run install packages in your cluster. And once you are actually connected, once you have it installed, the next step you want to do is connect. So in this case, we're going to use master equals yarn. As you might have remembered from previous videos, we usually use master equals local. And that's mostly because we've been using in a lot of the videos just a local cluster, which is much easier to set up for those of you that want to follow the videos. In this case, we're just using EMR, and EMR happens to run in yarn by default. So that's what we're using to connect. All right, so so now we're connected to a proper EMR cluster. And what we should do is launch the Amazon EMR Spark UI, which goes through a proxy, which requires you to fix a couple of the URLs, not a big deal. And there you go. We are using Spark 2.4.3 and we're connected. All right, so for this video, I want to show 4 different ways of uploading data into Spark. Now, most of the time, the data is already gonna be available for you in one way or another one in Spark, so usually you don't need to worry about uploading data sets. But in this particular video, I wanted to explain how, if you have the need to. So, the first concept that you should know about, which you're probably already familiar with, is the copy to function. So if we wanted to upload, for instance, the iris dataset, one of the comments that we can run is simply say copy to SC, which is our connection, and then we're gonna say, we can either say the datasets, or we can just say iris, and that's pretty straightforward. It basically what this command does is it loads the data into memory in the driver node and then pushes us to Apache Spark, which it's great, but as you might already know, this is not great for uploading large data sets. So why? Well, the way this works is, as I mentioned, it copies the data from the R session into Spark, which means that the data already fits into memory. And there's also some overhead from copying it. You can make it a little bit better by using Apache Arrow, which we've discussed in other videos. But basically the problem with this approach is that it needs to load into memory. And if the data needs to load, if you can load the data into memory, this basically means that it's not really a big data set and you probably don't need Apache Spark to process this data set. But it's still a valid way of uploading data as long as it's small. The use case for this particular data upload operation is if you have like a very large table and you have a small table that you want to cross join with in Apache Spark, you can upload the small table into Spark and then cross join it with the big one. Anyway, so this is one approach. Now the recommended approach to upload large data sets from Spark into Spark, if you know what I mean, like basically if we were to have a large data set in this particular machine, then what we can do is basically upload it directly into Spark without having to use R. All right, so how does that look like? Well, it looks as follows. So before we actually get started, let's first create a file, and this file is not going to be a large file. It doesn't really need to be a large file whatsoever. Just it's just going to be an example. So what we're going to do is we're going to write a few lines, and we're just going to say hello world, whatever, and we're going to call this file hello.txt. Now, the nice thing about this approach is that this could be one file or that is huge, or it could be multiple files. So as long as you have the files already in your driver node in EMR or whichever Spark cluster you're using, what you can consider using is the Hadoop tools to upload data into your cluster. So if you were to look at on the terminal, the way that you would use Hadoop is simply by typing Hadoop, which in EMR and many cloud providers, it's already a tool that is configured. So what we want to do here is use Hadoop FS, which is basically gives you access to the Hadoop file system. And then what you could do, for instance, is say ls. And basically all this is doing is listing what are the files that are available in Hadoop. So actually, before we get started, since I rerun through this little exercise before starting the recording of this video, let's just delete the hello text file that I previously uploaded. And probably I did something wrong. Yes, I mistyped rend with rm, which is the correct command. All right, so now it's clear. So let's start all over. And if we were to list the files in this particular, file system, we can see that there's nothing. There's only one file which is unrelated, and it's a file created by Spark. All right, so how do we upload this text file, which, again, it's not a big data set, but it could potentially be like a huge amount of information that doesn't fit in memory, and you want to distribute it into multiple worker nodes in Hadoop that Spark would use with multiple worker nodes, right? So the way that you would do that would be to say Hadoop fs, and then you would run the command copy from local, which is case sensitive. So make sure that you actually get the casing correctly. And then you basically want to say which is the source file, which is hello.txt, and which is the destination file in Hadoop. And again, this tool is a tool that is specialized in copying large data sets. So there shouldn't be any restriction on how much data you copy to Spark with this particular approach. So as you can see, we have a hello txt file here. And then what we could do is use the well-known functions that you might already be familiar with, Spark read let's just call Spark read text. And we're going to pass the connection. And in this case, let's just specify the path. And the path to this particular file is a little bit tricky to find because we're going to specify the full path. So I believe what we want to specify here is the full path to the user, which would be Hadoop / hello.txt. And also, we don't need to cache this into memory. We're just reading it. It doesn't matter, but this is a pretty small data set. But let's just try to do it this way because other data sets that we're going to load, we will want to avoid using loading them into memory. All right, so that's pretty much it. So this is our second approach. Our first approach was to copy data. This works for small data sets. Our second approach was to copy data using the Hadoop file system toolset into Hadoop and then just read it from Spark. And this is basically unbound to the number of files and the size of the files that you're uploading to Hadoop. Now let's take a look at a third approach. And the third approach is, so what happens if your data is not on the driver node? So if you're working with a local machine, say if you're working in this particular RStudio session, and if I were to have like a large data set, which I don't have in this case, but suppose that, this namespace file is huge, which again is not the case, but as you can see, I'm running RStudio locally, and I have a cluster over here, which is, not on the same location. If they were on the same network, you could also use the terminal and use Hadoop to copy data from the local machine to the cluster, but this only works if you have a local cluster and you have the appropriate connections and permissions and whatnot, which is not always the case. And it's definitely not the case when you're using Amazon EMR or, like Google Data Proc, Microsoft, HD Insight, IBM's, or Databricks, right? So they're on a separate machine, on a separate service, so we can't really just copy them directly. So one approach that we can do is we can use the Amazon AWS CLI. And I'm not gonna run a specific example on how to do that here because I don't have the CLI installed, or maybe I do. We can try that, but I'm pretty sure I don't have it installed locally. Yeah, I don't have the CLI installed, but basically one of the tools that you can use to upload data sets is, each cloud provider usually has a CLI tool, meaning a command line interface that allows you to upload data sets directly into their platform, and in this case to Amazon S3 buckets. So you would do something like AWS, I don't know what is the command, but probably something like copy, or maybe S3 upload, whatever, upload. And then the local path, hello.txt, and the remote path with the bucket and whatnot. So this is one approach, and basically what you would end up getting, once the data is uploaded, you would end up with something like looks like this. In this case, it's a pre-configured bucket, and then what you can do is once you upload the data into your Apache service, like in this case we have a data set already preloaded, you can basically then just read it. And usually reading it is quite easy if you have a service that is managed by the same company. So in this case, when you use EMR already comes from pre-configured to load data from Amazon S3. So even though this is a CSV file, let's just load it as text just for simplicity. If you have to actually load it as a CSV, you can just change Spark read text to CSV and deal with all the other parameters and configuration things that you are already familiar with. Anyway, so in this case, what you want to say is we're going to read the path, and we're going to say S3, which is our file system, is no longer Hadoop, but it's rather S3. And then we're going to reference our data set. This data set is actually much larger than our very simple example. So we're gonna save memory. Oh, actually, I was running the previous one with memory equals true. I actually meant to say memory equals false, whatever. Yeah, so this should work. So we're giving the path. We're specifying where the bucket is located, and then the path within the bucket to process this data set. So let's give that a shot. And again, just to recap, this is our third approach on how to upload data sets into Amazon EMR. So again, this is a pretty large data set, and we can count the number of rows if we wanted to, just for fun. Might take a while because it's, again, this is not a real cluster, even though it's a real cluster because it's running on Amazon EMR, but it only has one machine. If you were to look at the hardware for this particular cluster, it only has one machine. So I'm not gonna push the cluster this time too far. Anyway, so again, this is our third approach. We basically could have used the CLI to upload datasets into Amazon EMR. Well, we upload the datasets into S3, which Amazon EMR is already pre-configured to load from, and then we can just use Spark read text and process that particular dataset. And again, you can use basically all the tools that you already know from Spark, like read CSV, read JSON, read Parquet, read Avro, whatever. So it doesn't need to be a text file, obviously. All right, so the last approach that I want to mention, it's a little bit experimental because it's not yet in CRAN, but if you have followed some of our videos, you might already be familiar with a package called Pins. So one of the new features that we added on Pins that is currently on only available on GitHub, but the next release on CRAN would have this functionality available, is that you can basically also connect to cloud boards like Amazon S3, Google Cloud, and Azure to upload datasets. So in this case, I'm gonna connect to my S3 board. And if you were to say pin find board equals rpins, which is the name of the board that I gave it, you can see that there is a dataset called empty cars. And this dataset is looks like this. Basically, there's an empty cars dataset that is available, and why not? What we're gonna do instead is we're gonna use the pins package to upload different dataset. So we're gonna say pin. Let's see. What about the volcano dataset? That's not a CSV, but might be CLK. Where is the, we can upload, I guess we could upload the, I think I have the package here. We can just say airports, and this is a pretty small data set, so we can just play with this. All right, so what we're gonna do is we are going to upload the airports dataset. So let's just call these airports, and we're gonna upload it to our S3 board using the pins package. I don't know if I have pins loaded, so I'm just gonna say pins, airports, and then that's our data set. So this should work. It basically, what it did is it basically uploaded this data set into S3, which we can see now here. And yeah, that's pretty much it. And if you go to your S3 bucket, we should see here that there's a new airports dataset, and it actually also contains a CSV file, which is pretty small. So depending on your bucket, you might have to also explicitly make your files public, or you don't need to make them public. If this were to be the same account that you're using with EMR, then you can just use your datasets as long as your EMR account has permissions to look at this dataset. In this case, I'm using different accounts, so I'm just gonna make them public. And then what we can do is go back to the cluster and read it from that particular location. So we're gonna do something similar as what we did last time, but rather than using this existing dataset, we are gonna use the pins bucket that it's being registered on the board, and we call these airports, I believe, and then the name of the file is data.csv. Let me just check that. data.csv, and the location is called airports. Yep, and that's how the dataset looks like. And again, we should be able to read this. Again, in this case, I'm just reading it as a text file, but we can go one step further and also read it as a CSV, and why not? And now what we should be able to see is, this particular data set loaded into Spark. And again, the really cool thing is that we uploaded this data set quite easily using the pins package. All we had to do is register our S3 bucket, and now we can basically make use of our local data sets, even if they're large, or why not, we can upload them. We could potentially, multiple people could potentially also be uploading data sets, and we could all read them in parallel using Apache Spark pretty easily in this case. And since we're using the same cloud provider, right? Like we're using Amazon for everything. If you were to be using Google Cloud, it would probably be easy to use the pins Google Cloud board to upload the data set and then use Google Data Proc to process it. But and again, like the tools are different. Google uses a different CLI, which is called gcloud, but the approach is pretty much the same. You can either use the CLI to upload it or the pins package and then read it on your cloud provider's EMR cluster, or whichever cluster provider you're using for your Spark deployment. Yeah, that's pretty much it. I hope that you enjoyed this short video on how to upload datasets into Spark when using R, and we'll see you soon.